Do we have to wait or shall we start? Regarding the previous class, do you guys have any queries? Please let me know. If not, we'll start this today's session. Okay, thank you. Okay, so let's continue. And my request for you guys is that before coming to the class, just at least spend at least 5 minutes or 10 minutes, recall the topics what we have discussed on the previous class, so that we will be connected and we'll get better understanding for the today's class. Okay, so from the next class, just try to recollect whatever we have discussed in the previous class, and then it will be very helpful. Is my screen visible?
Visible, sir.
Yeah, okay, thank you. So as said in the previous class, we are discussing about forces and we discussed about the equilibrium equations, and we have also discussed about the free body diagram. So before going to further, let us discuss more examples on the free body diagram. Okay, let's start from the simple example. Okay, before that, let me ask you, in general, what is the difference between, or how do we classify a bar, a beam, or we can say it is a frame element or column? So what is the difference between these three elements? What do you think? These three will be same or they can be different? What is the primary function of a bar? Suppose if I take a bar like this, what is the primary function of this? Feel free to express your thoughts, guys. So nobody is going to score you here, and it's just the learning platform. So just start from zero. Okay. What is the difference between the, first of all, tell me, how do we classify a bar problem?
The axial
Or axial. Axial, right? So if it is a bar problem, so these will resist only axial forces, right? It doesn't matter whatever their orientation. They can be in horizontal direction, they can be in vertical direction, or they can be in any inclined direction. Only the thing is they will be carrying only axial forces. What is the best example for this? Problem. Column? Did somebody said column? Did I hear it wrong? I can say it is a best example as stress. As we know, they will only carry the axial forces, right? Either it may be tension or compression. If I talk about a column is also an axial load carrying member, but in addition to the axial force, moments can also act on the column. So if it is a bar, only I can say a truss is a best example for it. They will only transfer the axial forces. And what about the beam? What are the primary resisting forces for beam?
transverse
force.
For me, here I can say shear force and moments. Usually, in general or most of the cases, we will treat that beam elements are very, very axially rigid. Axially rigid means you don't have any elongation. They just move as a rigid body along the axial direction of the beam. So if you're talking about a beam, in most of the cases, I will tell you why I'm saying most of the cases in the coming sessions. But in most of the cases, if you are talking about a beam, they will resist the shear forces and movements. So in this case, if I want to represent a axial force in a bar, what I will do, I will draw a line of action along the length of the bar, and then I will represent a force along the direction. So this is what I will represent it as a axial force. If it is a beam, suppose if I am talking about this surface, I will represent this is my shear force, let us say, shear force I am representing it as a V, and then moment I am representing it as M. Okay, and if it is a, if you are taking any element in a frame, so here we will have axial forces, we will have shear forces, and also they will be subjected to the moments also. So before going to analyze of any problem, first of all, we should have clarity on these things. In this case, when to consider axial or when to neglect the axial forces, that we'll discuss now. Before that, let me just take a simple example. So here I am talking about a bar problem. So let me consider a bar AB. And let us say I'm just representing fixed surfaces A and B. Can you tell me how many reactions will exist at point A and how many reactions will exist at point B?
3, sir. 3.
At A, horizontal, vertical, rotation, and at B, you guys are saying horizontal, vertical, rotation. Anybody is going to object on this point? At A, 3 reactions will develop, and at B also 3 reactions will develop.
No, sir.
Everybody is going to agree this, right?
Yes, sir.
But I don't.
If it is
Sir, in
bar,
bar moment won't be present.
no moment close.
Yeah.
No moment
So
and
yeah. Thank you.
no moment and no shear.
Yeah. So first point, before representing the reaction forces for any support, so first thing you guys have to identify that which type of member that you are dealing with. Okay, as it is a fixed support and I am representing a 2D system, it doesn't mean that every time I will represent blindly, I will follow 3 types of forces like horizontal, vertical, and moment. Why? Because is that this is a bar problem. As we all know that if it is a bar problem, these will resist only axial forces. So only axial forces will be present in this member. So if only axial forces are presenting in this member, how come you will get the shear? So vertical means in this case it is shear only. How come vertical force will develop and how come movement will develop? They don't develop. So that's why as we are dealing with the bar problem, at end A, one unknown force that will be along the axial direction FA and another unknown force that will be axial direction at B. So total how many unknown forces here? 2. So if you're talking about this bar problem, here see, I'm specifically telling you that this is a bar problem. If I don't mention that, then blindly you have to consider 3. So here my point of taking this example is that if we are dealing with this specific type of problem, so according to that problem, you have to consider the unknown forces or unknown displacement or unknown internal forces, whatever the things you want to find out. So in this case, I can say that number of unknowns exist in this present case is 2. Now tell me, what are the equilibrium equations that this problem has to satisfy? Or what are the equilibrium equations that we have to consider for this bar problem?
Summation of H equal to 0.
I don't know what's the problem from here, you guys. Kindly, please type in the chat box so that I can see. I could not able to hear you guys clearly. Or you can just type in the chat box how many equilibrium equations we have to consider. We have to consider
1, sir.
2, 3.
1.
1. Okay, Ramya said 1. Everybody can freely shout, as hardly we are having 9 members or 8 members. So don't feel shy. Even it is a wrong, that is a learning step too. Okay, why? Because only 1?
Only in horizontal direction.
Only the unknown forces or unknown displacements, they will be generated along the axial direction only. even if I consider summation of forces y is equal to 0, even if I consider, or even if I don't consider, this value will be equal to 0. Why? Because the forces are not existing along the y direction, then how can you make them equal to 0? You can't, right? So wherever or in which direction the forces are acting, then you have to make the sum of forces along the direction is equal to 0. In this case, there is no point of acting forces along y direction and movement. So that's why even if you don't consider summation of f is equal to 0 or summation of moment is equal to 0, they will be automatically satisfied, or we can say that they don't exist. So in this case, how many equilibrium equations I will consider? In this case, if this is the direction z, then I can say that my forces along z direction will be is equal to 0. Now tell me how many unknowns I am having. For this current case, I am having the two unknowns. What are they? FA and FB. But how many equations I am having? Equilibrium equations. 1. So what is the indeterminacy here? So number of unknowns are 2, number of equations are 1. So my indeterminacy of the problem is 1. Is it clear about the indeterminacy of this problem, bar problem? I want all of you to respond in the chat box. As we are having strength is very, very, very low. That means we can one-to-one interaction should be there. Yeah, I can see most of you guys are typing. Damya, okay. Andal, okay. Ananita, okay. Thank you. Thank you so much. Now, what if I don't mention this as a bar problem? If I simply mention this as like this, I don't mention any loading and I just simply mention like this. What do you think? How many reactions we have to consider at point A and at point B?
Point A 3, point B 3.
So the difference here is that if nothing is mentioned, then we have to consider or we have to think in a generic way. Generic way means you have to treat it for all possible cases. Here I'm not saying any beam type of thing, nothing. So at point A, I can say that 3 reactions will exist, and at point B, I can say that 3 reactions might exist. So total how many forces are? 6. And how many equilibrium equations? As it is a 2D case, 3 equilibrium equations will exist, isn't it? So that's why total 6 unknown forces and how many equilibrium equations, as it is a 2D case, 3 equilibrium equations. So total, what is the indeterminacy? 3. That means we need 3 extra equations to solve this problem. Okay, is it clear for this case too? Now let me go for another case. Thank you. Just the same problem, I'm drawing it as a line element. Don't think that I'm drawing some other problem. Now tell me, how many reactions we have to consider at point A and how many we have to consider at point B? What is the difference between second case and third case?
Point A1, point B1.
Point A1 and point B1. Why so?
Sir, it is in a vertical direction, sir.
Vertical direction.
Load is in vertical direction.
Yeah. You want to consider only the vertical forces. Okay, before going, okay, that's a very good question. Let me clarify here itself. As most of you guys given a right answer, but still, let me explain you something. Okay. Let's say that I'm having some unknown force at P here. Okay. And let us say that I'm having the unknown force F here. Okay. Let us assume that this is what the fixed support and this is what the free body diagram I'm representing. So first of all, tell me what will be the unknown force FA. P and F are the applied forces. Imagine this is what your fixed support. That means we are solving the cantilever problem. Okay. Now, what is the at A? As we all know that, as it is a 2D case, 3 reactions will develop. So let us see how to find these 3 equations. First thing you have to remember is that because of the axial forces, rotations will not generate or movements will not develop. So this is what the first point that we should understand in our mind. For a beam element, or let me tell you, there is one problem, A, P, and also there is one more problem, A, B. Always remember, because of the axial forces, because the axial forces are acting along the line of action of the element. So that's why, because of the axial forces, movements will not develop in the element. So that's why, imagine there is a force that is acting on the right side F. We have to balance it. How can I balance it? Some force should act in the opposite direction. What is the equilibrium equation? Summation of force along X should be equal to 0. That means, how can I make this force equal to 0? By applying some resisting force in the opposite direction with the same magnitude. So instead of every time I am writing what is the direction and what is the reaction, here I can say that directly, as my at point B, applied force F is acting on the right side. To balance this, what I can represent it here? There should be some resisting force that should act in the opposite direction with the same magnitude. Right? If someone is pulling you on the right side, if some other person will pull you on the opposite side, then obviously both are equal, then you will stay there itself. So the same thing. Or even you can apply the summation of force X equal to 0, what you will get? F is on the left side and F is on the right side. What will be the net magnitude? 0. Similarly, what will be the vertical reaction that will develop at point A? Without any equations, by looking at this problem, I can say there is some vertical
Load
force
P.
P that is acting in the downward direction. How can I balance it? I can balance it by using same force
Opposite
by
direction.
applying in the opposite direction. So here at point A, what I will do? I will apply the force of magnitude P, but in the opposite direction. Now, summation of X is satisfied and also summation of Y is also satisfied. But look at these two forces. What we have to call these two? At point A, P is acting in the upward, and at point B, P is acting in the downward, and they are separated by a force L. What they will cause to the beam AB?
Couple moments.
So these are equal and opposite forces. Point A and point B, equal and opposite forces separated by a point, separated by a distance L. Now, these two are they are trying to rotate your member. They are trying to rotate your member in which direction? Imagine this is in the upward direction and this is in the downward direction. They are trying to rotate your member in which direction? Clockwise direction. Do you want to allow the rigid body rotation? We don't want to, right? How we will avoid it? By applying the movement in the opposite direction. So as these forces P, they will try to rotate your beam in the clockwise direction. To oppose the motion, what you should do? You have to apply resisting movement in the opposite direction. So where the resisting movement can develop? As it is a fixed support, that will not allow any rotation. So that's why the resisting movement will develop at point A. As these two are trying to rotate in clockwise direction, at point A, the movement will generate in the anti-clockwise direction. What is that magnitude? P into L. So from this we can observe that because of the axial forces, movements will not generate on the element. It doesn't matter whatever the orientation of the element. If axial forces are acting on the element, they will not cause any movement. If vertical forces or if shear forces are acting on the element, because of them, rotations may develop. To avoid that rotations, we have to apply the or resisting movements should develop. as you can come in this case, is there any applied forces acting on this element AB? Any forces along the horizontal direction?
No.
No, right? So that's why no axial force or no horizontal force will develop at A and no horizontal force will develop at point B. Instead, because of this force, two forces can develop. What is them? There may be a vertical reaction develop here and movement can also develop here. As we have discussed that if shear forces are acting on the system, in this case, as if shear forces are acting on the system, you have to balance the vertical forces and also you have to balance the summation of moment is equal to 0. That's why in this case, I can say that you have the unknown force that will develop along the vertical direction. There might be some resisting movement also will develop at B, at A. Similarly, there will be unknown force will generate along upward and also there will be unknown movement develop at B. So total how many unknown forces are generating? 2 plus 2, 4. Now tell me how many equilibrium equations I have to consider here.
2, sir.
Why? Because as there are no horizontal forces or no axial forces are acting on the system, even if I don't consider summation x equal to 0, this will automatically get satisfied. So that's why after avoiding these, I can say two equilibrium equations I can consider. So what is the indeterminacy? Unknown forces are 4, equilibrium equations are 2. So that's why what is the indeterminacy? 2. That means we need 2 extra equations to solve this problem. So is it clear? Any doubt in these 3 cases? In first cases, we have dealt with only axial forces. In second case, we have discussed in generic way. And in third case, we have discussed for specific loading case. Any doubt?
No, sir.
What do you think? See the indeterminacy value. In first case, it is 1. In second case, it is 3. And in third case, it is 2. Right? So, if nothing is mentioned in the question, that means you have to consider the case 2. If specific loads are given, then you have to go for case 3. For everybody, it's clear about number of reactions we have to consider depending upon the type of the force. Clear? If it is clear, let me ask. Yeah, please.
So suppose if we have 2 loads, means what we have?
In which direction?
In case
You're
3,
talking-
sir.
In case 3,
If
you
we
mean
have
like
2
this?
loads. Yes, sir.
It doesn't matter, right? Even these are also same thing, right?
Okay,
Only
sir.
we have to know. See, if this P is acting, then you might get reaction somewhere around, let us say, sorry, yeah. Because of 1 P, if you are having, let us say, if you are having P by 2 reaction force, if one more P is also acting, then what will happen? There will be one more force will come P by 2 by P by 2. If both adding, you are getting the value of P, let's say, let us assume. But ultimately, what is the unknown force direction? Only one, isn't it?
Yes, sir. Yes.
So it
Okay.
doesn't matter how many forces that are acting on the beam, but only the thing is that what is the magnitude of that reaction force you have to consider.
Okay, sir. Okay.
Let me give you a simple problem. Without explaining that, I am giving you a truss case, even though I will discuss this with you in a further classes. Just to get your clarity. This is a hinge, this is a hinge, and this is also a hinge. Okay. So as it is a truss, which type of forces they will transfer, or which type of forces will exist in the member?
Axial.
Axial forces will exist, isn't it? Let us assume that supports are A, B, C. Let us forget about whether it is, I can say this is a determinate case. Sorry, not a determinate case, it is a stable truss. Forget about whether it is stable or not. I mean to ask you, is that it is a determinate or indeterminate?
Indeterminate, sir.
Indeterminate to the degree?
To the degree is 3, sir.
Indeterminate degree 3.
2, 1, sir. 1, sir. Only 1.
Okay, just forget about, I'm talking about with respect to support reactions, you guys can tell me. Don't recall any formulas or don't think of anything. So,
Indeterminate
tell
to
me?
1, sir.
everybody will agree this? One unknown
Yes, sir.
reaction?
Only 1 unknown, sir.
Sir, one.
1, sir.
Wrong. I can say this is a determinate case. You can ask me, as it is a pin support, 2 reactions will develop. As it is a pin support, 2 reactions will develop. I can say there are 4 unknowns, and for the equilibrium, I have to say 4 minus 3, then 1. But why? Can you still think more and get me with some other value? Okay, as I said, determinate, obviously the value is equal to 0, but can you still think? Then one
Sir,
reaction,
the BC
What?
member is carrying 0 forces, sir.
BC,
BC, AB member is carrying 0 force, or BC member, any one member is carrying 0 forces, sir.
Only vertical reaction is taking. Sir.
yeah, the point is here, see, at support A, reactions will develop through. How the reactions will transfer, or tell me how the load P is transferring from B to support C and B. Forget about which member is carrying force, which member is not carrying, forget about it. How this load is transferring through support A and B? This load will transfer to the support A through the member AB. Similarly, this load is transferred through the support C through the member BC, isn't it?
Yes, sir.
Yes, sir.
Now, tell me, I'm telling you that these are the truss case. If it is a truss member, which type of forces the element will carry over? Which type of forces they will
Axial.
carry? They will carry only the
Only
axial force,
axial.
isn't it?
Yes,
So,
sir.
member AB will transfer which type of force to the support?
Vertical force.
As it is resisting only the axial force, so it will transfer only axial force to
Axial.
the support A, isn't it?
Yes,
In
sir.
this
Yes.
case, what is the direction of the axial force?
Horizontal.
The element orientation is truly vertical direction. So, that axial force direction is vertical. So, as this support is connected to the member AB, as member AB is oriented along the vertical direction, as these are the truss case, this will transfer only the axial forces. Because of the load P, this member will AB will transfer only the vertical forces to the support A. So what is that support? That reaction direction is vertical direction. Even though we think that, or even though this support is capable of taking both horizontal and vertical direction, but because of the arrangement of this truss, only vertical force will transfer through the support. There won't be any force that will transfer along the horizontal direction. So, in this case, at support A, I will consider only one force, that is upward direction. At C, I can consider both. Why? Because here the member is in the inclined direction, isn't it? If I draw the line of action, the line of action may be somewhere like this. This is what the reaction force in the member BC. But if you resolve this force, then what will happen? You have vertical component and also you will have the horizontal component also. So that's why at C there is a possibility of forces generating in both the direction. So in this case, at A, I will consider only one reaction. At C, I will consider both. So the net value is 3. Equilibrium equations are 3. So 3 minus 3 is equal to 0. Any doubts? In this case, why I have considered only one unknown reaction at support A?
Sir, this is because of inclined member in trusses cases, or it will be in framed structures also, sir.
No, not for
Are we
frame.
considering
Thi-
only for trusses?
Yeah, this is only for the truss.
Only for the trusses we
If
are
it is a,
considering.
if it is a frame will resist, as we have discussed, axial force, vertical force and moment. So the frames will develop, they will transfer all types of forces to the supports. So this is not true for the frame examples. So that's why here we are clearly said that this is for the truss problem.
Sir, can you explain more, sir?
Sorry, can you please repeat what you said?
He
Okay.
said to explain also.
Can you please type in the chat box?
Sir,
Yeah,
sir, if the member AB is, it's not a vertical, it means what will come, sir? It,
you mean like this, isn't it? You're talking about this case?
just a minute, sir.
Yes?
Yes, sir, yes, sir.
Yeah, obviously. But still I can say this is determinate. I will tell you why in the coming classes. Okay?
Okay, sir.
Why it is determinate, this we will discuss clearly while solving the trust problems, or I can tell you now itself. You guys have some idea about trust cases, right?
Yes, sir.
Okay, now if I take this example, before that, let's say, okay. Imagine there is a force acting like this, P, okay. And consider this angle is theta. Imagine this is the applied force. You have to find out the resisting force at point A. Okay. Now, what is the first point that you have to say? First thing is that if the forces are not truly acting along horizontal or vertical direction, we will resolve them along the corresponding directions, right? So if I resolve this force along the horizontal direction, how much I will get? If I resolve this force along horizontal direction,
P cos theta.
the angle with respect to horizontal, so x component is P cos. So the other side it will say it as a P sin theta, isn't it? Now,
Yes, sir.
if I want to consider free body diagram at point A, so I am considering these are my forces P cos theta, and this is my force P sin theta, isn't it?
Okay,
Now, how many reactions will develop at point A?
sir. Sir.
2. As it is a hinge support, there might be some unknown force. Let us say unknown force Fy, and also there might be some unknown force Fx. Right. If this is in equilibrium, then obviously it has to satisfy the equilibrium equations, right? So how many equilibrium equations we have to consider here? Do we have to consider summation Fy0, summation Fx0, or summation of moment Z equal to 0? Do we have to consider these three equations? Or can we omit anyone? Here the point is, I can omit the summation moment Z equal to 0.
Only
Why?
two,
Because
sir.
why I can omit this?
Only axial force.
No,
It's
not
trust,
just
sir.
because of that. See, all the forces we are resolving at which point? We are considering the free body diagram of point A, isn't it? Either Fx or Fy, P sin theta and P cos theta, all these forces are transferring through which point?
A.
Point A. That means these are all. Because of this, any force, do you think movement will generate at point A?
No, sir.
Movement is nothing
Distance.
but a force into perpendicular distance, right? As all
Yes,
these
sir.
three forces, sorry, all these four forces is acting at point A, as there is no distance, right? That means because of the forces, there is no movement will develop. Otherwise, one more point here is that if you are talking about free body diagram at point, so if you are considering free body diagram at point, then you can say that movements will not develop. So that's why we can consider only two equilibrium equations. So even if you don't consider movements will not develop, so there is no possibility of external movements that are acting at point A. And then by looking at the equations, you can simply say, right, what could be the reaction effects? As P cos theta is acting on the right side direction, then how you can balance it? There is an external force P cos theta that is acting at point A, that is acting along the right side direction. How you will balance it?
By opposite directions.
By opposite direction. So here initially I have represented right side direction, but instead what I can say?
Left side direction.
Balance it. I will consider a force P cos theta that will consider in opposite direction. Similarly at point A, what is unknown force? P sin theta that is acting in upward direction. How can I balance it?
Downward
Balance
direction.
it by applying some reaction in the downward direction. What is its magnitude? P sin theta. Is it done? So if you know, or if there is any reaction that is acting inclinedly, the support to reactions we can find out by using the equilibrium equations itself. Just like the same case here, because of the point P, by considering the equilibrium equations at this point B, I can find out the force in this member and I can find out the force in this member. And if I know force in this member, I can find out the force at this support. Similarly, if I know the force in this member, I can find out the force at this support. So that's why this will be classified as a determinate case. We will again discuss these cases in the while analyzing the truss problems. As of now, at least, did you guys get an idea why it is determinate?
Yes, sir.
Sir,
Yeah, please.
sir, if there is a horizontal load at point B, then will it become a frame, sir?
If there is,
A horizontal load of point B.
if there is some horizontal load at point B, right? Let us say this is 10 kilonewton, isn't it?
Yes, sir.
Now tell me, look at the supports. Forces at support A that will transfer through which member? So can I ask again? Through which element for reactions will develop at support A? Through element AB? Right or wrong?
Yes, sir.
Similarly, at point B, through element, sorry, this is already I have turned it as B, so let me say this is C. At support C, the forces will transfer through BC, isn't it?
Yes, sir.
So always you have to think that it doesn't matter which type of forces will exist, but if you look at this point, are you increasing any numbers? At point B, there are only two members are meeting. Just like in this case, I told you, if you are talking about the equilibrium equations at a point, or if you are talking about the free body diagram at a point, how many equilibrium equations it has to satisfy? Two, right? Not only in a truss problem, wherever you consider, if you are talking about free body diagram at a point, always we have to satisfy these two conditions. Why? Because as it is a point, we may not define the rotation. So that's why always we have to make sure that these two equations should satisfy. So if you are talking about free body diagram at a point, two equations they has to satisfy. If you are having two equations, that means how many unknowns you can solve there? At point A, in this case, two equilibrium equations are there. That's why how many unknowns you can solve it?
Two.
Two.
Two unknowns.
Just like here, if I take the equilibrium at point B, how many members are connected at point B? Two.
Two.
That means can I solve it by using the equilibrium equation summation of x equal to 0, summation of y 0? Can I?
Yes, sir.
Yes, sir.
That's why in this case, it doesn't matter whether horizontal forces develop or vertical forces will develop. As at point B, two members are connected. If I take the equilibrium of point B, I can find out those two unknown forces by using these two equilibrium equations. That's why still I will classify this case as a determinate case. Is it okay now?
Yes, sir.
Sir, but we have to consider for all the supports, no, sir.
You have to
What about-
consider
All the support reaction, no, sir.
if
What
I
about the support C, sir? Can you show the next slide, sir?
yeah.
Yeah, here we have mentioned FBD at point A, two equilibrium equations, sir.
Yeah,
And what about C, sir? The same will be
Yeah.
happening.
let me come to you.
Yes, sir.
Let's discuss as we have already dig into this problem. Let me solve this problem. It will be clear. As I told you, if a structure is in equilibrium, then did you guys remember I told you, if you take the entire structure that has to satisfy the equilibrium equations, or if you take an element, still they has to satisfy the equilibrium equations, or if you take a single point, even it has to satisfy the equilibrium equation. Why? Because if a structure is stable, each and every point or each and every part of the structure should be stable. Do you guys have any doubt in this case? Let us say this is A, this is B, and this is C. In a first way, what I will do, I will consider the free body diagram of entire truss. How can I represent the free body diagram of entire truss? I will remove the supports B and C. This is what the entire truss I have considered. This is what the load 20 kilonewton acting in the upward direction. This is what the load 10 kilonewton. Now tell me, how many reactions will develop at point B?
Two.
Two, right? There will be
Two,
some
sir.
unknown force here. Let's say vertical force VB. And also there will be some unknown force, let's say horizontal force HP. Similarly, at C, how many unknown force will develop?
Two, sir. Two.
So let us say there will be unknown vertical force VC, unknown horizontal force HC, right? As of now, any doubt? No. So in this case, if I take the equilibrium of entire truss, how many unknowns are there here?
Four, sir.
Four.
2 plus 2, 4,
Four, six.
isn't it? How many equilibrium equations we have to consider?
Two.
Two.
Two, sir.
One thing, let me clarify you here. We are taking the equilibrium of entire structure, isn't it? This is not a single point we are talking about. We are taking the equilibrium of entire truss. Tell me one thing, because of the 20 kilonewton force, whether movement will develop at point B or not? Because
sir,
of the
no,
20,
no.
movement will develop.
Yes,
Isn't
sir.
it?
Yes, sir. Sir, pass.
So how many equilibrium equations we have to consider?
Three.
Three.
3. So what is the indeterminacy?
One.
One.
That means if I simply draw the equilibrium of entire structure, indeterminate is showing it as 1. But still, now, instead of drawing for the entire truss, what I will say, I will draw equilibrium of or free body diagram at point A. At point A, first of all, represent the forces, applied forces. 20 kilonewton, and here 10 kilonewton, isn't it? Any other forces will exist? We don't know the reaction set here in AB or AC, right? So let me represent. I will remove the member and let me represent. This is what my internal force generated in the member AB, and this is what my internal force generated in the member AC. Do you guys agree with this? Any doubt here? Any doubt in free body diagram of point A? Now tell me, how many unknown forces are there?
2.
2, right? So here we are taking equilibrium of a point. If you are taking equilibrium of a point, how many equilibrium equations we have to consider?
2.
Everybody is in doubt that why you have to consider 2, or for you is it clear?
2 only, sir.
So it is clear.
Yes, sir.
Because when we resolve, this becomes a horizontal and a vertical. There will be no moment.
Yeah, as all the forces are passing through one point, there is no chance of developing movement. So that's why no need to consider summation of moments equal to 0. It's simple as it is. Now tell me, what is there any indeterminacy here? 2 minus 2.
No, sir.
0.
0. That means if I take free body diagram at point A, then I can find out the unknown forces in members AB and AC. As of now, clear?
Yes, sir.
Now,
Clear, sir.
what I will do next? Can you guys imagine? After this step, what I should do? My ultimate aim is not only to find the force in the members. My ultimate aim is to find out the support reactions also. Now I have found out my force in member AB, my force in member AC. Then what is the next step then? What about the reactions at B? And what about the reactions at C? Isn't it? Again, what I will do? I will take the free body diagram at point B. At point B, if I draw the free body diagram, how many forces will exist? Reaction force in the member will exist, isn't it? So let us say this is what the reaction force in the member. How much? RAB. And similarly, how many reaction forces will generate at point B? Support B. 2. As I don't know them, let us imagine that VB, HB. This is what the support B. Now, how many unknowns are there here? Already,
2
if I
unknowns.
take the equilibrium of point A, I already can find out RAB. I can already find out RAC. That means RAB and RAC are known quantities now. Now, how many unknowns are there in this equation?
2.
Unknowns are 2. What are they? HB and VB. How many equilibrium equations we have to consider?
2.
Again, we are
2.
solving free body diagram at point B. 2. So 2 minus 2, 0. That means I can find out VB and HB, isn't it?
Yes, sir.
Similarly, can I do it for the support C?
Yes, sir.
Just like the same thing I did for B, I can do it for C also. That means, did I use any extra equations here other than the equilibrium equations?
No, sir.
Is it clear? So tell me, determinate or indeterminate this case?
Determinate.
So that means determinacy or indeterminacy, sometimes you should not always judge it by looking at the entire structure. Sometimes it is always possible that if you look at the arrangement of the members, then it can be determinate also. Is it okay about the statement that I gave? Is it clear?
Yes, sir.
Can I
Yes,
go
sir.
further? Somebody is asking something. Yeah, please. Is any question somebody is asking? Sorry,
No,
guys.
sir.
Yeah, okay. I think Ravi Kumar,
Sir?
you guys are following, isn't it?
Yes, sir. Yes, sir.
Okay, fine. we can, so guys, as hardly I can see only 9 members, excluding me, I can see only 8 guys are present. So one-to-one interaction, if it happens, then it will be very beneficial for you and for me also. So always try to interact and try to stop me wherever it is or wherever you guys are facing difficulty. Okay. Do not think that we are deviating from the syllabus. We should always learn through examples. Okay. So these problems will help us a lot while understanding the or while defining the indeterminacy. Okay. Now let me come to you again to the basic problem that I want to discuss with you is okay. Now tell me, determinate or indeterminate?
Determinate but unstable, sir.
Only one question. Determinate or not, that's it.
Not
Determinate.
sir. No sir.
I need to hear from the guys who don't agree that this is a determinate.
It is determinate.
No
Why
sir.
it is why it is sorry, who is saying no? I think, can you just explain why it's no? It's not like our regular class program that I'm going to scold you, or I don't have any your internal marks.
It is a determinate only.
Yeah. Why it is determinate? Because you can ask me, as there are roller supports are given, these beam
And
can move along the horizontal direction, but you can look at the type of force that I given on this problem.
Vertical.
As vertical force is given, then this force can be easily balanced by the vertical reactions at the supports. As horizontal forces are not acting here, then no, there is no need of
Momentum.
horizontal movement, or no need to consider summation fx equal to 0, waste of time. Why? Because as no forces are acting, then why will you waste your time by considering the summation of x equal to 0? Now my point is, who's the one who said it is unstable, is it okay? Somebody saying this is indeterminate, sorry, not stable. P C L by 2 L by 2. Determinate or indeterminate?
Determinate, sir.
Determinate. Don't. Yeah, determinate. Very, very silly problem. Now, I want to draw free body diagram of AB, and then I want to draw free body diagram of AC, and then I want to draw free body diagram of AB, CB. Okay, here my motive is not whether it is determinate or indeterminate. My motive is you guys should know the how to draw free body diagrams. Now tell me, if it is AB, I think every one of you can tell me the answer, isn't it? How many reactions I should consider at A?
2.
2. Vertical and horizontal. How many I should consider at B?
1 sir, vertical.
That is vertical. So there is no ambiguity here at all. Right? Now, let me come to AC. And this is the point A and this is the point C. Now tell me, how many reactions I should consider at A?
2 only sir.
As I have not considered supporter, then I can say here upward. How many I should consider at C?
4. 3 varum sir.
3, right? Why?
Sir.
Because at point C, I am separating it from the beam. That's why at point C, internal forces will exist. So here as I have mentioned you any forces, if nothing is mentioned, you have to consider all possible internal forces. So
Yes, sir.
here there will be an internal forces that can be in 3 directions. So the internal force, let us say horizontal force along direction, there is an internal force along vertical direction, and also there will be an internal movement, let us say that is MC. Any doubt in free body diagram of AC?
No, sir.
Right? Now similarly come to the CV. Similarly can tell me at C, how many
Three,
internal forces I
three.
have to consider? 3.
3, sir.
Right.
3.
What is the horizontal direction that I should consider?
Anti-clockwise.
Here I have considered it as on the right side, right? So here I should consider it as a
Left side,
left
left.
side, HC. VC I have considered in the upward. So here I will consider it as a downward VC. Movement I have considered in anti-clockwise. So here I will consider it as a, and as usual at B, I will consider only
Upward direction.
one, right? Now, even you can understand the indeterminacy for each individual part. What is the indeterminacy for AC?
One, sir.
If I look at the entire problem, if I look at the free body diagram of entire problem AB, is there any indeterminacy? Forget about these parts. First, we have considered the equilibrium of entire beam. Is there any indeterminacy?
No, sir.
No,
So-
0, right?
Zero.
That means I have already found these 3 reactions. Now look at the free body diagram of AC.
2, sir.
I have already know these 2, isn't it?
Oh.
The first step is I have already considered the equilibrium of entire truss, and then I have obtained that this may be 20, this may be 10, and this may be 22. So this will be 20, this will be 10. Now tell me, how many unknowns are there in the part AC?
3.
3. How many? If this is in equilibrium, then unknown forces are 3. How many unknown equilibrium equations we have to consider?
3.
3.
That means what is indeterminacy?
0.
0. Similarly here, I already know these 3. That means these 3 are already known. And this is also already known, isn't it? What is the difference between this beam problem and this truss problem? Can you tell me what is the major difference that we have, that we can identify from these 2 problems? This truss problem and this beam problem. What is the major difference
We
that we
didn't
can
consider
identify?
moment.
It is inclined, sir.
No, it's not about moment, it's not about incline.
We
Here,
we
in
didn't
the,
consider the equilibrium equation for moment.
in the truss problem, how we have find the unknown forces? By considering the entire structure or by coming from the internal part, subparts. In this case, first we have find the unknown forces from the free body diagram at point A, isn't it? And then we have came to the supports. But here what we have done? First
In
we have
supports,
found
we have found out
reactions
internal.
and then we came to the internal. That means it's always vice versa. Depending upon the problem, sometimes first we have to apply the equilibrium equations on entire truss or entire structure, and then you have to apply it on the subparts. Or like in the truss problem, first we have to solve the equilibrium equations of the subpart, and then you have to consider the, you have to go to the external part. Okay. Now, if I'm talking about, again, I'm coming to bar problem. A, C, B. And AB. How many reactions will exist at A and B? It is a bar problem. Once again, I'm saying.
2.
At A, how many reactions will exist?
1.
Always don't get confused. It is a bar problem, only axial forces. And at B, how many?
1.
One, sir.
One. This is the free body diagram of AB. Now consider the free body diagram of AC. At A we already know 1. What about at C?
3, sir. 3.
3. Everybody will agree? Everybody will agree that at C, 3 reactions, 3 internal forces will develop. Do you guys agree?
No, sir, only one.
Yeah, that's why
Only
I'm telling
axial.
you. We should not always go blindly. This is a bar problem. That means it will restrict or it will resist only the axial forces. So even if you cut at any point, how many internal reactions it will, you can see only the axial internal force only you can see. So even at point C, you can only see one reaction. Why? Because as it is a bar problem, they will resist only the axial forces. Similarly, you can look at CB. We have know already at C1 reaction will exist and at B1 reaction will exist. Is it okay? Any doubt on this problem?
No, sir.
Clear? Are we going very slow or we are going on the correct pace? If we are going slow, we can increase the pace.
So it's okay, sir.
Fine.
Fine, sir.
As of now, any doubt? As of now, free body diagrams, equilibrium equations, forces. I hope no, right? And let me take you to the another step. Not only whether it is known one or unknown one. Determinate or indeterminate, I mean to say.
So undeterminate.
Indeterminate, what is the degree of indeterminacy?
1.
1, isn't it? Okay, thank you. Now, how can I make it as a determinant? Tell me some possible options. How can we make it as a determinant?
By introducing hinges.
That means number of reactions should decrease, right?
Yes, sir.
That means if I remove support B, determinate or indeterminate?
Determinate,
Determinate,
sir.
sir.
At A, I have considered a fixed support. Instead of fixed support, what I can say? I can consider pin reaction or hinge reaction. Still it is determinate. Any other possible ways? Any other possible ways to make it as a determinant? Only the one thing is
We can apply.
somehow
No.
either we have to decrease one reaction or I can create one additional equation. In both the case, it will be determinate, isn't it? If I decrease one reaction, then what will happen? Unknown forces will be 2, equilibrium equations 3, 0. If I increase one additional equation, that means 3 plus 1 equal to 0. So here, let us say that I am considering the hinge at point C. How you will define an internal hinge? You guys might encounter, right? What is meant by internal hinge? What it will do to the structure? If it is internal hinge, you guys might have heard if it is an internal hinge.
-1 something. Say that.
If it is an internal hinge, it won't able to resist any movement. Right. That means it won't have any capacity to resist the applied movements. That's why the movement at internal hinge will be equal to 0. Okay. So wherever there is an internal hinge, you can say that the movement will be equal to 0. Now, I want to draw the free body diagram of AC now. If I want to represent free body diagram of AC, for now tell me how many reactions will exist at point A?
3.
3. Horizontal, upward and movement. And what about at point C? Similar problem we have seen, right? See here. At point C, how many reaction internal forces are
Two,
considered
sir.
here? 3. But here, do we have to consider 3 internal forces?
No, sir. Two.
No, sir.
We
Will
should
be
not
0.
consider 3. Why? Because as it is an internal hinge, movement will be equal to 0. As movement equal to 0, then why will you consider that? So instead, there will be only 2 reactions will develop, HC, and here how many? VC. Similarly, you might know, if I say CB, here it will be HC, and here it will be VC, and here it will be only V. Right? Is it clear?
Yes, sir.
Now, before going to explain you the determinacy or indeterminacy, first of all, I want to give you a small task that this is the internal hinge. Here the reaction I am getting it is at 20. Here the reaction I am getting it is at 20. Here the reaction I am getting it as 40. Let me look at it once again. Here the distance is 2 meter and here the distance is 2 meter. A, B, C. Now what I am going to discuss with you is that tell me the equation for summation of moment at point C. Tell me, what is the summation of moments at point C?
20 into 2, 47.
No, tell me don't tell me the answer. Tell me the equation like 20 into 2, 20 into 2, 40 into
20
2.
into 2 only,
Huh?
sir. 20 into 2 only.
20 into 2.
20 into 2 only.
Is it right?
No, sir. And minus 22.
Here, let us say that you are considering clockwise as positive. To be clarity, if there is a clockwise movement, consider it as a positive one. Tell me.
Okay.
20 into 2 minus
22
into
minus
2.
20 into 2.
What about movement at point C?
0.
0.
What is the difference between these two? First of all, I want to get the clarity of these two. What is the difference between summation of moment at point C and what is how to define moment at point C?
Summation of movement is including all the forces acting on the
Yeah.
member.
That means if you are talking about a point at C, you have to consider all possible movements that are acting at point C in any direction. It doesn't matter whether you look into left or look into right, it doesn't matter, but you have to look into all directions. So because of this 20, at C movement will develop 20 into 2, that will be in clockwise. So plus 20 into 2. Because of this 20 also movement will develop 20 into 2. And then it is in anti-clockwise, that's why minus 20 into 2. But what if I say movement at point C? That means wherever if I say movement at one particular point, here this value, either you can find it from or just simply say, look it from only one side. It doesn't matter which side you will look into, but you have to look it from only one side. Imagine that you have kept your hand at point C. Look into the right side direction and tell me what is the movement at point C.
40, sir.
If you look at your hand at C, if you look into the right side, how many forces are existing on the right side? Only 120, that is an upward. So what is the movement at point C? 20 into 2. What is our
40.
sign convention? If it is a clockwise, you have to consider it as a positive. So because of the upward 20, it will be anti-clockwise direction. So minus 20 into 2. This is what if you are looking it from right side. Similarly, keep your hand at point C and look at it on the left side. Again, there is upward force at point A. Because of that upward force, what will be the movement at point C? 20 into 2. That will be in clockwise. So plus 20 into 2. This is the moment if you are looking from left side. If you add these two, how much you should get?
0.
Is it clear now as it is summation of moment at C and moment at C? Why? Because this is also a common mistake where the students are committing mistakes. If it is clear, then I will tell you, I will go to the previous problem.
Cleared, sir.
Okay, now. Now our task is to know whether this is the determinate case or indeterminate case. Why I am solving the problem here is that if I tell you simply by using equations, you guys might get forget. But if you understand with some example, then it will be remembered long time. So, how many unknowns are there in this case? At A, how many reactions will exist?
3.
2, sir.
In
Four,
general, you can say it is a 3 or 2, it doesn't matter, but at the end of the day, you will end up with only 1. But as I am representing this is a vertical force, I will be happy if you consider only 2. What are they? Upward and
RA and the moment.
movement. Let us say this is the unknown reaction at A, an unknown moment at A. And here how many reactions will develop at B?
Only one, sir.
Only one. What is it? Unknown
Yes.
reaction at B. Now total how many forces are there?
3.
3. How many equilibrium equations we have to consider?
2, sir.
3.
Here are
Two,
we
sir.
considering any horizontal force?
No,
sir.
sir.
No,
But
then
we can
there is no
introduce
need to
moment.
consider the summation of x equal to 0. That's why 3 minus 2. That will be equal to 1. But we are having hinge at point C, isn't it?
Yes, sir.
What is the property of the hinge? If there is a hinge, then there won't be any
Moment
internal
is
movement.
0.
Moment 0,
So
vertical.
that means we are having one additional equation. What is that equation?
Vertical, sir. VC.
Movement at point C is
Moment at
equal to
point
0.
0.
If it is an internal movement at point C equal to 0, this is what your one additional equation. So if I write down clearly, unknowns, what are they? VA, MA, and VB. Now tell me, what are the equilibrium equations? Tell me in terms of equation, not in terms of 1 to 1 like that. What are the equilibrium equations? Summation.
Vertical.
F,
Summation.
Y
Y
equals
is
Equal to 0. Summation of
Summation.
moment equal to 0. And in
MC
addition to the equilibrium equations, one
and
additional
MC equal
equation,
to
what is
0.
it? Moment at C is equal to 0. Now tell me, how many unknowns and how many equations? 3 unknowns, 3 equations. So this is a determinate or indeterminate?
Determinate.
Determinate. So now tell me, let's say suppose if I take moment at point C equal to 0, okay. Tell me the equation if you look it from left side. What is the moment at point C? Look at this diagram and tell me. Moment at point C, look it from left side and tell me what is the equation you will get.
VA into
V into 3.
Minus
VA into
MA.
3. Let us say
Minus
you are
MA.
considering clockwise is positive.
So
Okay, sir.
minus MA plus VA into 3
VA into
equal to 0.
sorry, VA into 3 minus
Minus
MA is
MA
equal to 0.
equal to 0.
Similarly, look it from, tell me from right side. Look it from right side and tell me.
VB into 2. Minus
VB
VB
VB.
into
Minus VB.
minus VB equal to 0.
VB into 3 equal to 0.
I think you can understand, right? By looking at these two, by using which side, we can directly getting one unknown reaction.
Right side.
If you look into the right side, you can tell me, right, what is the reaction at B?
VB will be
2, sir.
0.
0.
So how many remaining equations are pending? Summation f by 0 and summation mz equal to 0. By using those two, can you find out the remaining equations? Sorry, remaining unknowns. Weekend, is it?
Yes, sir.
That means, so always remember that
Yes, sir.
before dig into the equations or before blindly writing big equations, first you should think in your mind that which equation you should apply such that I can directly get some unknown values. So this will always come from the practice. If you're always blindly going from the left, what do you think? Do you really think your problem will be much easier? No. So always we have to identify the equations that will leads you to give you directly some unknowns. It is not always possible for every type of structure, but it is possible for some type of structures. But especially as you're writing the competitive exams, these are the crucial points that you have to stress on. Because just like your exams, regular exams, if you keep on writing and solving the equations, your time won't be sufficient. So always there will be some logic. With that, you can directly get the answer in a minimal steps. So that is what your target should be for learning the analysis course. If you're not able to identify these small things, then there is no point of taking these courses. And okay, I think you got the point, right? So try to understand and try to think in such a way that you should get the answer in very minimal steps.
Sir,
Yeah, please.
sir, the moment about G, how to come equilibrium equation, sir?
Moment at point C.
How to come in equilibrium equations?
Sorry, but I could not able to hear properly. I don't know whose problem is it. Can you please type it? Sorry for the inconvenience, please. See it again. I will try to understand. Are you typing? How come MC as equal? Oh, no, that's not equilibrium equations. That's an additional equation. Sorry, I said it is and so take it from additional equation. Okay.
Okay, sir. Okay, sir.
And let me give you one more example. Now tell me, I want to draw the free body diagram here itself. What is the free body diagram for AB? Here there is unknown reaction, sorry. There is some unknown reaction and also there is some movement. Now tell me, how many unknown forces I should consider? How many internal forces I should consider at point C here in this case?
2, sir.
What are they?
Vertical and horizontal. Here,
Let's see how many internal forces I should consider.
only vertical, sir. Here.
Only vertical. Why? Because as it is a hinge, already movement is 0, isn't it?
Yes, sir.
That means here I will consider only one vertical force. Do I know this value? I don't know, right? So again, imagine it as an unknown, VC. Unknowns are VA and MA. VA and MA. And coming to the CB. Let's see. I don't know here, but I can say as it is considered upward, I can say it as VC. And I already know this reaction, right? What is the reaction here?
VB.
VB.
We got it as 0, isn't it? As it is 0, no need to represent, right? Is it okay?
Yes, sir.
Now tell me, what about this additional force 20 kilonewton? Where I have to represent that force here in this case? First of all, tell me what is this reaction? Look at this CB. You can apply the equilibrium equations. Forget about, first of all, load at that point. Forget about it. Or imagine, if it is complicating you, forget, do one thing. Remove this and place somewhere here. Just for the sake of now. So 20 will be somewhere here. Now tell me, what about the reaction here? Can you apply the equilibrium equations for the section CB? What are the equilibrium equations? Summation of x equal to sorry. Summation of y equal to 0.
F is equal to 0.
Summation moment equal to 0. So what will be the reaction here? Why you guys are taking so much time? Is there any ambiguity?
So only one reaction only will be. Only one unknown, sir.
Yeah. Here I can represent it as RB. But what is this value?
0.
Now tell me, what is this value? VC should be
0.
0.
sir.
That's it. That means this member CB, is it taking any force?
No, sir.
No, that means it is not taking any force. So no force it is taking. If it is 0, then what about this value?
0.
This is also
That is
0.
also 0.
0. So if I read simply VA, MA, and there will be some force here, 20. Can I find these two or not? How? Again, I will apply the equilibrium equation for this section. Summation of y equal to 0, and then summation moment equal to 0. Right?
Yes, sir.
That means these two also can be solved. Isn't it? So is it clear, this problem? Why everybody?
Okay, sir. If it act at exact AC means what will come, sir?
That I will tell you, but I don't tell you right now, but definitely we'll solve those type of problems also. But let us clear some concepts of determinacy. If I again start explaining this, that might be again complicated.
Okay.
Other than that, forget about the load at what point it is acting, but other than that, is it okay?
Yes, sir.
Okay, fine.
Okay. Clear, sir.
Okay, now let me give you one more simple case. Can you tell me what is the indeterminacy? Or before that, let us solve this problem, okay? Can you, how many unknowns are there, first of all? How many unknown forces are there? In this case, how many reactions I should consider at A, 1 or 2? Always remember, this is not a simple beam problem, isn't it? There is one vertical element also. If it is a plane problem, don't hesitate to take origin, consider all the forces. So at A, how many I can consider? 2.
2.
Upward and horizontal. At C also, 2 might be possible. And at B, 1.
1.
So total, how many?
5, sir.
5.
5. Equilibrium equations.
3.
Say total unknown indeterminacy, 2. But how many additional equations we have? We have additional hinge at point D. Isn't it?
Yes, sir.
That means how many extra equations we will have?
1.
So this is where I want to think about you guys. This is not 1.
Sir, 2, sir.
I can say this is 2, but I want to hear why it is 2.
3 member or 1.
Why, can you tell me? In the previous case, we have considered only one additional equation, that is moment at point C is equal to 0. But in this case, why I am considering 2?
The number of equations considered is m minus 1.
Number of indeterminacy 2, sir.
Number of?
Indeterminacy
The number
2.
of additional equation to be considered is m minus 1. Here m is number of members. At the hinge point, the member is missing 3.
Again, guys, don't tell me with formulas. Why it is m minus 1? Tell me.
Sir, D is the common point for A to B and C and C to D.
Is it because it is a common point? That's why we have to say, what is the rule? Why you're saying it is m minus 1? Or even here, this is problem we have solved, isn't it? Moment at points that we have seen clearly how we have to solve. But here, didn't you guys get the question that
3 members are there.
why can't I consider two additional equations? Why I should consider 2 here? Why not 2 here?
Sir, here 3 members at a point D, sir.
Okay, there are 3 members at a point, but the question is why?
No idea, sir.
Come on, think about it. Why? I have already, the answer is here. Let me write you. The answer is here.
We have two unknowns, so we are considering two
See,
additional
if
equations.
you know these two are known or not? If I know, see here, if I am representing HC's right side, which force I am representing at this point? HC on the
Left side.
PC.
left side. Instead, let me tell you a simple example, okay? This is not a hinge. I'm just concentrating here, okay? Don't treat it as a hinge. A, B, C. I want to draw the free body diagram of AD, BC, and DC. Let me represent the moment here. Here, what about the moment? In the member AD, can I represent it as MDA? What does it mean? Movement at point D towards the direction A. Similarly, what is the movement I should represent here?
DB.
Movement at point D towards
D.
Similarly, what is the movement I should represent here? Movement at
Moment at
point
DC.
D
DC.
towards C, isn't it? Now, MDA, is this movement in the element or movement in the joint? MDA is nothing but a movement in the element AD. Similarly, MDB is nothing but a movement in the element DB. If I ask you, what is the movement at point D? What is the movement at the joint?
All 3 moments.
MDA plus MDB.
It will be nothing but a movement at DA plus movement at D towards B plus movement at D towards C. Is it right?
Yes, sir.
Now, what is our case here? My case is that if there is a hinge at point D, what will be my movement at point D? What should be my movement at point D?
0.
0, sir.
0. Right. There should not be any resisting movement, isn't it? That means this value will be 0, this value will be 0, this value will be 0. Don't tell me that I'll consider plus 10, minus 5, minus 5, then also it is 0. The point of hinge is that there is no resisting movement at that point. That's it, okay? Don't tell me with all the algebraic forms. Is it right? As there is no resisting
sir.
movement at point D, MDA should be 0, MDB should be 0, MDC should be 0, isn't it? Now, if I can tell you that MDA is 0 and MDB equal to 0, what will be my MDC? Consider this case. Consider this case, and if I am telling you that my MDA is 0, MDB is 0, what will be my MDC value?
0.
Why? Because
Moment in the hinge 0.
At point T, moment is 0.
that means if any two movements at that point is 0, then obviously what about the another thing? That will automatically 0, isn't it?
Yes, sir.
Just like we have discussed previously here, that
Are we
considering horizontal reactions or are we considering summation of x equal to 0?
No, sir.
Why? Because even if you don't consider it, it will be 0. Just like in the same case, if out of these three, if any two are 0, then what will be the another one? That will also be equal to 0, even if you consider that equation or even if you don't consider that equation. That means you can say MDA is equal to 0. How you will find out MDA? As of now, is it okay? The logic that 2 should be equal to 0 and remaining 1 automatically 0. Do you guys agree with that?
Yes, sir.
Right?
Yes, sir.
Now tell me, now let me tell you that. Now, for the same problem, in how many ways I can find the moment at point D? Yeah, let me write down. B, C, and D. I can find out moment at D. From A, I can find out moment at D. I can come from B. I can find out moment at D. I can come from C, isn't it?
Yes, sir.
I can look it from one side, and also I can look it from one side, and I can look it from what I can see it here. Indirectly, I can say this is MDA, this is MDB, this is MDC. So moment at point D, I can represent either come from A, or I can come from B, or I can come from C. That means indirectly you are taking the element moments. That means I can say MDA, MDB, MDC. As the logic is that MD should be equal to 0, or summation of moment at D should be equal to 0, because it is a hinge joint. If any of these two 0, then third one will automatically get satisfied. So that is why always we will say that. So if more than 2 members are connected, we will say that number of members minus 1. Number of members means 3 different movements are possible in this case. If 1 more member is added, then 1 more member will come into picture. That means 4 different movements will be possible. Out of those 3, if 3 are equal to 0, what about the another one? That will also be is equal to 0.
0.
So is it clear now? Now in this
Yes,
case,
sir.
what is the answer? After subtracting the equilibrium equations, 2 unknowns are there. Out of those 2 unknowns, as hinge is there at the correctly, so 3 minus 1, 2. So that's why this is also a determinate case. Any doubts? Now, let me tell you one more example in the same problem. What is the difference between previous one and this one? What is the difference? Can you identify the
Hinge
difference?
is not a joint, sir.
That means here,
Hinge is not a joint.
the hinge is not exactly at the joint. The hinge is in the vertical member, very, very close to the joint. So here, how many unknown forces are there, first of all? 2 here, 2 here, 1 here. Unknown forces are 5. How many equilibrium equations?
3.
3, 2. Now, how many additional equations we have to consider here?
1.
1 sir.
1. Why? Because it. What is that one additional equation?
1 touchy 1.
MDC is equal to 0. Is it right? So only one additional equation. So what is the indeterminacy? Indeterminacy is equal to 1. Clear?
Yes sir. Yes sir.
As of now, I think we have covered very basic. So let me tell you one more thing also. Okay. Now, let me come to the frames. Classic example that we are going to discuss here. Determinate or indeterminate?
Sir.
I think you guys have already know the answer. You can guys tell me. So, as I am telling you, as of now, we have in most of the examples, whatever we have seen the determinacy with respect to the external supports. But here I will tell you, if you are talking about indeterminacy, there are 2 indeterminacies are possible. One is external indeterminacy and another one is internal indeterminacy. So now we are going to discuss the indeterminacy with the point of these 2. External indeterminacy means this is the indeterminacy that you are getting through because of the unknown support reactions. Internal reactions you are getting because of the arrangement of the members. Okay. Now, first of all, tell me, what is the external indeterminacy? That means just look at the supports only. If there is some loads acting like this, 10 kilonewton and 20 kilonewton. Can you guys find out the reactions quickly? Can we or cannot?
They consider, sir.
Look at the supports. How many unknowns will be exist here?
2, sir.
So that is 1. Right.
3,
side.
sir.
3, totally 3, sir.
Totally 3, right? So how many equilibrium equations?
3, sir.
3.
That means these 3 can be solved, isn't it?
Yes, sir.
One force, you can tell me quickly. What is that force? By looking at this, you can quickly tell me one unknown force. Can you tell me what is it?
Sir, horizontal is equal to
Yeah. Here see,
Minus
horizontal
20.
is 20. How many horizontal reactions are there? Only one. If it is 20 acting on the right side, to make it summation of forces equal to 0 along x, how about this horizontal reaction here?
Towards left side, sir.
So this always should be left side, that is 20 kilonewton. Then what about these two? These two we have to solve it by considering moment, summation of moments at any point is equal to 0. I am not doing just because it will be taking time or not needed. But this we should understand. Whichever is easily can be find out, that you guys have to know immediately. Now, so because of the supports, there is no indeterminacy to the structure. That's why what is the external indeterminacy? 0. Do you guys agree with this? External indeterminacy is 0.
Yes, sir.
Now coming to the internal. So without explaining you in a formulaic way, let me solve it for you. Okay. Now, let's say this is A, B, C, D, E. Now let me draw the free body diagram. Let us say after solving, I got this as 5 kilonewton. I got this as 5 kilonewton. Let us assume it. Okay. Now, can you tell me what is the free body diagram of AB? You guys are understanding my writing, right? I am very bad at writing. You guys don't have any problem, right, as of now?
Understand, sir.
no, sir.
Thank you so much. Okay, this is A, B. At A, we already know the reactions, isn't it? Upward 5 kilonewton, left side 20 kilonewton.
20.
So here, upward 5 kilonewton and the left side. This should be also in equilibrium, isn't it? If entire structure is in equilibrium, this will also be in equilibrium. How many reactions will internal forces will exist at point A?
2.
2, right? What are they? 2. Why 2? It is a frame. Horizontal in a axial force will exist, shear force will exist, and also resisting moment will also develop. So 3 will develop. Now tell me, by looking at the type of forces, one force I can directly represent it. What is it? Can you tell me? 2 forces I can represent it easily.
20
See,
kilonewton.
So
a force
vertical is
acting 5
equal to 5.
kilonewton. How can I balance it?
Downward.
5 kilonewton. Any doubt?
And
If
then
D is acting on the left,
right side.
then what should be the value here?
20.
Let us say this length is 2 meters. Look at the 20 kilonewton here. Which forces are creating the couple? 5 kilonewton force or 20 kilonewton force?
20 kilometers.
20 kilonewton force, right? These are creating couple in which direction? Clockwise or anti-clockwise?
Clockwise.
Clockwise.
Clockwise. sir.
Clockwise. See? This will create a clockwise. What is that moment? 20 into 2?
40.
40. That means these two forces are trying to rotate your member by a magnitude of 40. But you should not allow it. How you will make sure that? By applying movement in the opposite direction. How much we have to consider?
40.
40.
20
40,
into
sir.
40.
40.
Is there any doubt in these three forces? Please let me know.
No
For
doubt,
anybody.
sir. No doubt.
All of you will agree, right?
Clear. Yes, sir.
Yeah, thank you. Now, coming to the BC, let me write for BC. Tell me, this is B and this is C. How many forces will exist at B?
Three.
3, right? Do I know their magnitudes?
3, sir. 3. Vertical,
3,
horizontal.
3 will exist.
Vertical,
Do I know their
vertical,
magnitudes?
Yes, sir.
5 kilonewton. Yes,
5
sir.
kilonewton upward. Everybody will agree
Left
to this?
side. Yes.
Yes, sir.
Everybody or anybody is disagree? Everybody will agree that 5 kilonewton upward at point B in the member BC.
Yes, sir.
If you guys agree, I will still represent the other forces. Agree,
Yes,
right?
sir.
Agree, sir.
Agree, everybody. If I am saying, after I am asking this so many times, then one should think there might be a problem. And even if you don't know, just tell me you don't agree. We'll discuss that.
At the point we have 5 kilonewton upward.
See, at B, how many members are connected here? At B, how many members are connected?
3 members.
Two members. Three members.
Previously, there are 2 members, but in the present case, 3 different members are connected. So if I represent that member, it will be B. Previously, we have discussed that if only 2 members are there, if we add them, you should not get any net reaction. That's why you should get it as 0. That means if you are separating members at a point, if we again add them back, then you can say that summation of anything will be equal to 0. These are what the equilibrium conditions. That's what we can apply here. But instead of 2 members, we are having the 3 different members are connected at point B. That's why I don't know exactly what is the force here. But what I can say, I can represent there is some unknown force. Let us say VB, and also there will be some horizontal reaction, HP, and also there will be some unknown moment. Similarly, here also the reactions are not known. Let us say VB dash. Let us, sorry, I represented it wrong. HP dash, upward, VB dash, and also moment MB dash. But what will be my equilibrium equations at a joint? If you again join back them, you should not have any net force. So that's why at a joint B, if I add summation of forces in one direction, 0. Summation of forces one direction, 0. Summation of moments is equal to 0. At B, now tell me how many forces are existing? At B, I have divided into 3 different members. So what is the net force at point B along horizontal direction? How many horizontal forces are acting at joint B? 20 is also horizontal direction. HB is also horizontal direction.
3, sir.
HB dash also horizontal direction. That means if I add all those values, that is what nothing but my force along X direction at point B. That will be equal to how much, tell me?
20.
20 if I take right sides are positive. 20 plus HB dash also I am considering it as a right side. HB is also I am considering it as a right side. Similarly, what is the net force at Y? Along Y direction at B. Again,
5 kilo minus
5. If I consider upward force is positive, 5 is acting in the downward. So
minus 5
minus 5 plus VB plus VB dash is equal to 0.
Plus VB dash.
Similarly for the movements also, isn't it?
Yes, sir.
Previously, what happened,
Minus 40.
as you are having only 2 members, one reaction you have directly shown it in the opposite direction. But here what happened is that Instead of 2, we are having more than 2 members. That's why we are not directly knowing these values. Now, did you understood? HB,
Yes, sir.
VB, and MB are not known. HB dash, VB dash, and MB dash are also not known. Is it okay as of now? Do you guys agree till this point?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, imagine that these 3 are known. Just imagine. These 3 are known or not?
Known, sir.
If these 3 are known, by applying these 3 equations, I can get these are the unknown, isn't it?
Sir. Yes, sir.
Agree? Now keep these 3 aside. Let me come to here. If these 3 are known, if I write the equilibrium of member BC, can I find these 3? Imagine equilibrium in BC. Now these 3 are known. If I know these 3,
Yes, sir.
can I find this
Yes,
reaction
sir.
just like
Yes, sir.
sir.
Yes, sir. Yes, sir.
right? Again at member C, how many members are connected? 2. If I know this, can I know reactions here?
Yes, sir.
Are you guys getting confused or can I explain more in detail?
Clear, sir.
Just like going one element by one element and we are applying equilibrium equations only. Here, we know these 2. We have applied equilibrium equations on AB. We found these 3. And then we have resolved this joint, but we have got some forces. As already we have seen, if we imagine these 3 can be found. So, right, we have considered the equilibrium of BC. As these 3 are known, by using the equilibrium equations of BC, these can be found. Again, if you look at joint C, how many members are connected? 2. If 2 members are connected, at one member, if forces are known, what about the forces in other members? Opposite direction.
The opposite.
Opposite
Yes, sir.
to the.
That means if these are known, these are just opposite. If these are known, can I found here?
Opposite to D, sir.
No, by using
Opposite.
equilibrium equations.
Yes, sir.
Similarly, in member, if these are known, these are opposite. Again, if I take equilibrium, I can find out this. Again, at point E, how many members are there?
3, sir.
3 members. So if I resolve them, look at the member AB, B. I know this. That means I can find out this. Already I have this. Let me do one thing. Let me continue in the next class. Otherwise, I don't want to be in a hurry to explain this problem because this will clearly give you the idea of internal forces and how to solve it. Okay, we will solve it this problem clearly. Is it okay? In the next class, we will solve it in a numerical way instead of explaining this and this. At least as of now, any doubts? Till this point, 3 unknowns. If you are clear, then we'll continue in the next class.
Clear, sir.
Yeah, please.
Sir, at point B, what about the summation of M equal to 0?
You have to find.
The state will be come like MB dash and 40 kN, sir.
Can you please ask me once again?
So you have written only 2
At
equations.
point B, summation of
Fx
M
equal to 0.
Here,
Yes, sir.
Point B, what
What
about
about
moment?
summation of moment?
that will also be there. I haven't written that's it. As you guys are clearly about it. Here I haven't written that's it. It will come. Moment at B also will come, but I have not written. Just as you guys understood, right? But the same problem we'll solve it tomorrow. And
Okay.
we'll clearly know how many additional equations are required. Okay.
Yeah, yes, sir.
Fine. Can we stop today for this? Okay, just before coming to next class, just
Yes,
think
sir.
about this problem and then we'll continue.
Okay,
And
sir.
without wasting much time, just from the next class. In next class, we'll complete kinematic and static indeterminacy and we'll see. Okay.
Okay, sir.
Okay. Thank you guys. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.